Hello everyone, this is the last example of chapter 5. In this example, we have branching pipes. Pipe 1 is connected to two pipes, as you see, pipe 2 and pipe 3. Those are continuous pipes. Also, we can understand it from those ending shapes. Those shapes correspond that pipes are continuous, and as well we have pressure there. Those are not open to atmosphere. So that, let's continue with the text. Neglecting losses so that there is no friction loss. And again, as there is no friction, there is no friction force. It is asked to determine the reaction force in y direction necessary to fix the branching pipe in the horizontal plane as shown. So that we are looking for a force that will be applied to this system in order to keep it in its place. So that we are looking for the force to be applied to the system and also the force on the water. Let's initially indicate that force like this as Fy. We just assumed a direction. That direction is not important at the beginning. At the end, we are checking, And surely we need to select our control volume, and we are selecting the whole volume because all the flow properties related with sections 1, 2, and 3 are given to us, and we need to insert those sections as the control sections that we have flow through those. And surely, as force is asked, we need to write momentum equation. Let's write momentum equation in y direction. General formula, surface forces in y direction plus body forces in y direction equals initially the unsteady term plus the momentum flux component in y direction. Surface forces are pressure, friction, and external forces. And please note that we have pressure forces in all three sections. P1, A1 in this direction. I cannot plot it well, but P3, A3 in this direction and P2, A2 in this direction. So that let's insert those in our equation. We have P1, A1 in the positive direction. And we need to look for the components of those two. Initially for P2, as this angle is 45. Let me plot here. This angle is also 45. And we are looking for this component of P2A2, which will be the force itself multiplied by sine of the angle in the negative direction, minus P2A2 sine 45 degrees. Similarly, for this one, as this angle is 60, this angle is again 60 degrees, so that we need to again look for this component for the y direction. It is P3A3 sine 60 and in the negative direction. force component. There is no friction, but we have this external force. And again, please note that nothing about, sorry, not nothing, but it is given that it is on the horizontal plane, so that we don't have weight component. Just we have minus Fy, because that was our selected direction in the minus y direction. This term is 0 because we have steady flow. And let's go through with the momentum flux terms. Momentum fluxes are always pointing outward from the control volume, and as velocities should be defined as constant velocities, this term, drops to rho v square a, so that the momentum flux at section 1 will be rho v1 square a1 in the negative y direction, minus rho v1 square a1. Let's go through with section 2. Again in the outward direction, rho v2 square a2, and note that this angle is 45, and again we are looking for sine of that force, and in the positive direction, rho v2 square a2 sine 45 degrees. Similarly, for section 3, outward direction, rho v3 square a3, and this angle is 60 degrees, multiply by sine 60, and it is a positive force, rho v3 square a3 sine 60 degrees. Now this is the equation. We need to solve for Fy, but please note that discharge is given, pipe diameters are given, and we need to find out all velocities from it, so that we can find out velocities. What else given about pressures? Just P1 is given. P2 and P3 are not given, so that we need to find out those. Before following our momentum equation, we need to find out initially the velocities, then afterwards we need to write down energy equations in order to find out pressure terms. First, the velocities. Q1 is given as 0.17 meter cube per second, and from here we can easily calculate V1, 4Q over pi d1 square. d1 is 0.54. This gives us V1 equals 0.74 meters per second. V2 is already given here, as you see. V2 is 3. But what about V3? You need to also find out V3. In order to find it out, we need to write continuity equation. Please note that in this control volume, Q1 is inflow, Q2 is outflow, but nothing is given about Q3. So that initially find out here Q2 3 square over 4 equals 4.21. As you see, Q1 is 0.17, Q2 is 0.21. Outflow is greater. This means that Q3 is also an inflow. Of 0.04 meter cube per second. And from here, V3 can be calculated. 4Q3 over pi D3 square. 4 times 0.04 over pi D3 is 0.15. 0.15 square. This gives us 2.26 meters per second. Now we need to find out pressures and note that there is no friction and everywhere total heads are same. So that we need to carry out this H1 equals H2 equals H3. Energy is totally conserved. By using this one, we have just two unknowns, P2 and P3. P1 is known, so that just using the equalities, H1 equals H2 and H1 equals H3, we can find out the unknown pressure terms. H1 equals H2 gives us Z1 plus P1 over gamma plus V1 square over 2G equals Z2 plus P2 over gamma plus V2 square over 2G. We have this pipe laid out in a horizontal plane so that elevations are same, cancel each other. And from here, let's continue from here. P1 was given 70 kilopascal divided by 9.81 kilonewton per meter cube. And V1 was 0.74. P2 is unknown. And V2 was 3. From here, P2 is obtained as 65.77 kilopascal. Similarly, let's continue from here. H2 equals H3, let's say. And this gives us Z2 plus P2 over gamma plus V2 square over 2G equals Z3 plus P3 over gamma plus V3 square over 2G. With a similar manner, horizontal plane elevations are same, cancel each other. And from here, P2 is here, this divided by 9.81 plus V2 is 3 equals P3 unknown plus V3 is here. From here, unknown P3 is obtained as 67.72 kilopascal. Okay, recall that this was our initial momentum equation, and now we obtained each and every unknown term let's continue from that equation. Initial first term P1A1, 70 kilopascal multiplied by pi 0.54 square over 4 A1 minus P2 6577 multiplied by pi 0.3 square over 4 sine 45 minus P3 here 6772 pi 0.15 square over 4 and sine 60 surely minus Fy. The left hand side is okay, and let's write right hand side to the bottom equals minus, follow from there, 1000, and note that we need to convert the right hand side terms to the kilonewton so that we are dividing those with 1000. That was V1 square A1 0.74 square pi 0.54 square over 4 A1 plus rho V2 square A2 and sine 45. V2 is this, A2 is this, plus again rho divided by 1000 for unit conversion, V3 square A3 multiplied by sine 60. V3 is this, pi 0.15 square over 4 sine 60. And as you see, this is the final form of the equation, and on the unknown is Fy. From here, we can calculate Fy equals 11.3 kilonewtons. And as you see, also, we need that something more. As you see, we found it as positive. This means that our initial guess for the direction is correct. This initial guess, so that, okay, no problem. So that the direction is through downward direction. Okay, that is the end for this solution. I hope you understood it well.